Hi, welcome to my channel, Math Made Easy with Laurel. I'm Laurel, and in this video we're going to take a look at the quotient rule of finding derivatives. In the previous video, we talked about the product rule, which I've just listed here. And one thing that I want to point out with both product rule and quotient rule, we use these rules when we deal with functions times functions, or functions divided by functions. If you have a constant, if u is a constant, you don't need to use the product rule. Similarly, I don't need to use the quotient rule if either the numerator or the denominator is a constant. For example, if I have y equals 5 over x squared, all I need to do to differentiate this is rewrite that as 5 times x to the negative 2, and then we differentiate it the way we learned a couple videos ago, has to be negative 10 x to the negative 3. So we don't need to use the quotient rule if either the numerator or the denominator is constant. However, I see students doing that all the time, and it's just making life tougher than it needs to be. It's not wrong, but it's just going to be more work for you. So let's focus on a function divided by a function. The derivative of my function will be equal to v times the derivative of u. And then instead of adding, I have to subtract. And then it's u times the derivative of v. And then the whole thing is over v squared. There are 3 errors that I see students typically do. They get the order wrong. They add instead of subtract, and they forget about the denominator. This is just something you're going to have to learn and remember. Let's take a look at examples to see how this rule works. In my first example, I actually picked an example where I could simplify it. So this function would actually be 5x to the 4th. And then I can differentiate that, so my derivative would be 20x cubed. Knowing what the answer is, let's do this quotient using the quotient rule, and that way you can see that the result is the same. Again, I would suggest that you identify the u and the v and find u prime and v prime, maybe in the margin of your page, and then plug into your formula. So u is always going to be the numerator, which is 5x to the 6th. So u prime will be the derivative of this, which will be 30x to the 5th. V is the denominator, which is x squared. The derivative of that will be 2x. So let's plug those values into our formula. The derivative of my quotient will be v, which is x squared, times u prime, which is 30x to the 5th, minus u, which is 5x to the 6th, times v prime, which is 2x, all over the denominator, or v, x squared, squared. So let's simplify this. So I have 30x to the 7th minus 10x to the 7th over x to the 4th. And that will be equal to 20x to the 7th over x to the 4th, which is 20x cubed. So I just wanted to do this question so that you could see the formula worked. Let's try some more. So in my next example, there's nothing I can do to simplify that before I differentiate. So I am going to jump right into using the quotient rule. I'm going to identify u, which is the numerator, 3x squared, v, which is the denominator, 4x plus 5, and then I'm going to find the derivatives of each of those functions. The derivative of 3x squared will be 6x. The derivative of 4x plus 5 will be 4 plus 0, which is just 4. Now I'm going to plug into my quotient rule. The derivative of this function will be v, which is 4x plus 5, times u prime, which is 6x, minus u, which is 3x squared, times v prime, which is 4. All of that over the denominator squared. Another thing you need to be aware of is that when you're doing algebraic simplifications, you can only cancel factors. This 4x plus 5 is a factor of this term, but it is a term. And then you have another term over here. You cannot cancel it. I see that so often. You may only cancel common factors of the whole numerator and the whole denominator. So if that was a factor of the whole numerator, then you would be able to cancel it. But it's just a factor of one term, you can't. So I just want to warn you about that. What we need to do now is just simplify this algebraically. So we're going to do our multiplications. We have 24x squared plus 30x minus 12x squared. There's no reason to expand this. I'm just going to leave it as 4x plus 5 squared. And then I've got like terms. 24x squared minus 12x squared would be 12x squared plus 30x over 4x plus 5 squared. Now you might be asking yourself, should I factor my numerator? You can if you want, but the only time you should do it is if it allows you to cancel with a common factor in the denominator. If we were to factor, we could factor a 6x out of both terms, and I'll be left with 2x plus 5. Because that didn't allow me to cancel any common factors, it wasn't necessary. So that's the only time you'd need to factor your numerator, is if it allowed you to simplify your result further. So I'm just going to leave it unfactored, and I'm just going to leave my denominator factored. Factoring or not factoring doesn't simplify an expression, but canceling common factors would simplify it. I hope that makes sense to you. Let's take a look at a few more examples. Our next example is displacement as a function of time. So we've just changed variables, but we still do the same process. U is always the numerator, so t cubed minus 2t. V is the denominator, so 4t plus 1. Now we're going to differentiate u with respect to our independent variable, which now is t. So the derivative of u will be 3t squared minus the derivative of 2t is 2. Similarly, I differentiate this with respect to t, so my derivative is 4. Now I plug those into my formula. So ds dt will be equal to v, which is 4t plus 1, times u prime, which is 3t squared minus 2, minus u, which is t cubed minus 2t, times v prime, which is 4, the whole thing over v squared. Again, we cannot cancel that 4t plus 1. What we can do is simplify our numerator by expanding and combining like terms. So I'm going to FOIL this. I'm going to have 12t cubed minus 8t plus 3t squared minus 2. Then I expand here, and remember that negative has to be applied to both terms. So it's going to be minus 4t cubed minus a negative is like adding a positive. So that's a plus 8t. Now I combine like terms. I have 12t cubed minus 4t cubed gives me 8t cubed. So I've got that term and that term. Then I have plus 3t squared. I usually go in descending order of the degree of the term. So your highest exponent and then decreasing. So I've got that. Minus 8t plus 8t, I've got that, that's just a 0, and minus 2. Now I don't know if this could be factored, but all I'm interested in is if one of the factors was 4t plus 1, and it isn't, so I leave it in that form. Let's try one last example. This example is similar to one I did in the last video, but I made them a product. I just want to address it again. When you have a function of x, we know it's a function of x, but you don't have numbers as your coefficients, you have letters. We treat them the way we treat numbers. We know that they're constants, we just don't know their value. So u would be my numerator. My denominator is v. And I differentiate them, each of these, with respect to x. X is my variable. So I treat a as a constant. So the derivative will be a times the derivative of x squared, which is 2x. So 2ax is the derivative of this term, minus b times the derivative of x. Derivative of x is 1. So this is the expression for the derivative of this function with respect to x. I do the same thing with this function. C is a constant. Take c times the derivative of x, which is 1, plus d is a constant. The derivative of a constant is 0. Those are my derivatives. Now I plug those into my formula. So f prime of x, notation for derivative, will be v, which is cx plus d, times u prime, which is 2ax minus b, minus u, which is ax squared minus bx, times v prime, which is c, all over v squared. So cx plus d squared. Again, I cannot cancel that. That's not a factor of the whole numerator, it's only a factor of a term. What I can do is expand by foiling this. So I'm going to get 2ac, and then x times x is x squared. So I put the 2 in the a and the c because they're all constants, I put them out front. Minus bcx plus 2adx minus bd. Now I multiply both terms by c, and remember I'm subtracting, so it will be minus acx squared, minus minus gives me plus, I don't need that anymore, bcx, all over my denominator, which I'm going to leave factored. And now I can combine any like terms in my numerator. So I have a 2acx squared minus 1acx squared, so that gives me 1acx squared. Okay, so I got both of those. Then I've got minus bcx plus bcx, which is 0, got those. Then I have plus 2adx and minus bd all over my denominator squared. So if you have functions like this, don't be alarmed. Just follow the rules like we've been following and just realize that these are numbers, we just don't happen to know what the numbers are. Practice quotient rule, practice product rule if you haven't. We're going to be continuing using these rules as we grow our repertoire of finding derivatives. So you want to be very comfortable and confident with these. In the next video, we're going to talk about the chain rule. Make sure you know this before moving on. All right, take care and we'll see you then.